Welcome to the lesson on resistance. In this lesson, we will explore the concept of resistance, the factors influencing resistance, and its importance in battery electric vehicle, abbreviated as BEV systems. Let us look at our lesson objectives. By the end of this lesson, you will be able to define resistance and explain its role in BEV operation. Next, you will be able to explain how resistance affects current flow in a BEV's electrical system. You will also be able to identify the factors that influence resistance in a BEV's components. Finally, you will be able to describe the relationship between current, voltage, and resistance in BEV circuits using Ohm's law. The successful and safe servicing of a BEV requires a strong foundation in electrical fundamentals. One of the most crucial concepts is understanding resistance. Resistance dictates how easily electricity flows through a conductor within a BEV's electrical system. BEVs incorporate components that contribute to electric resistance, including wiring and connectors, batteries, and electric motors. In this lesson, we will focus on the concept of resistance, the factors affecting resistance, and the relationship between current, voltage, and resistance using Ohm's law. Resistance is the opposition a material offers to the flow of electric current. It's like friction in electricity, making it harder for electrons to move freely. Resistance can be compared to the width of the pipe. As depicted in the image, a pipe with a large diameter will have low resistance compared to a pipe with a small diameter with a high resistance. Resistance is measured in units called ohms, represented by the Greek letter omega. A resistor is a component that opposes the flow of current in an electrical circuit. Resistors can be used to limit current, divide voltage, or generate heat. Resistance is a critical factor in BEVs as it affects the efficiency of the electrical components, such as motors and batteries, and influences the range and performance of the vehicle. Considering a fixed voltage, resistance can change depending on various factors, including the length of the conductor, cross-sectional area, material properties, and temperature. Length of the conductor. The longer a conductor, the higher its resistance. A longer path means electrons have more material to pass through, facing more opposition to their flow. Cross-sectional areas. Thicker wires have lower resistance because they provide a larger pathway for electrons. Material. Different materials have inherent properties that affect their ability to conduct electricity. Conductors like copper and aluminum have low resistance, while insulators like rubber have high resistance. Temperature. For most materials, resistance increases with temperature. Ohm's law describes the relationship between three key electrical quantities: current, voltage, and resistance. For example, if a technician is troubleshooting a headlight malfunction, the technician suspects a problem with the wiring harness. Ohm's law resistance in ohms is equal to voltage in volts divided by current in amps is used to estimate the resistance in the circuit. The technician measures the voltage at the headlight socket, for example, 12 volts. The technician will know the current draw of the headlight from the vehicle manual, for example, 5 amps. Applying Ohm's law, resistance equals to 12 volts divided by 5 amps. Resistance equals 2.4 ohms. This value represents the total resistance in the headlight circuit, including the wiring harness, bulb filament, and other components. By analyzing resistance using Ohm's law, a technician can identify the faulty component and perform repairs to ensure proper headlight operation. Let us now recap what we have covered in this lesson on resistance. Resistance acts like friction in electricity, dictating how easily current flows through a conductor. Various components contribute to a vehicle's overall resistance, from wiring to batteries and motors. Resistance is the opposition a material offers to the flow of electric current. Measured in ohms, resistance is like the width of a pipe. A wider pipe has lower resistance, allowing easier flow compared to a narrow one. Resistance can control current, divide voltage, or create heat. Several factors influence resistance, including the length of a conductor, cross-sectional area, material, and temperature. Analyzing resistance through Ohm's law helps identify faulty components, allowing technicians to ensure proper repairs. Understanding resistance and its influencing factors is important prior to working on BEVs. Thank you.